Hai, selamat sejahtera guys. Hari ini kita sambung lagi on logarithm and solving equations related to index. Kita mula dulu dengan definition of log ya. So if you have a power y equals to x, where a is greater than 0 and a not equals to 1, and x is a positive real number, then you can rewrite the equation in index form ni to a logarithmic form of y equals to log x base a. Okay, so for example, you have 10 to the power of 2 equals to 100. This is in index form. This index form is equivalent to the logarithmic form of 2 equals to log 100 base 10. Alright, let's look at another example. Firstly, we have a power 5 equals to 32. So this form is equivalent to log of log 35 base a equals to 5. So sebenarnya you are taking log a on the left and right side saja kan. Okay, and here you can also rewrite the index form in logarithmic form as log 2 5t plus 3 equals to x, ataupun terbalik pun boleh lah. Okay. Alright, now let's look at the properties of log ataupun laws of logarithms. Okay, if you have a, x and y are positive real number and a cannot be equals to 1. So kenapa a cannot be equals to 1 is because a is the base kan. Base cannot be equals to 1. Dia kena 2, 3, 4 and so forth lah. Okay. Alright, so the first property is if you have log xy base a equals to log x base a plus log y base b. Kenapa ada b? Taklah, buku ni cacat lah. Sorry, ni cacat lah. Yang ni A patutnya lah kan? Should be lah, right? Okay, the second one is if you have log x over y, that will be equals to log x minus y lah. Yang ni you tahu kan? Log 1 base a will be equals to 0, any base of a lah. Okay, log a base a will be equals to 1. Yang ni if you have log x power c base a, this is equivalent to c log x base a. C can be any real number. And then yang ni apa base dia? Sama je lah kan? Okay. Yeah, this one is using property 4 also kan, sebab you akan dapat c log a base a. So log a base a is 1, so you akan dapat equals to c. So a power log x base a akan sama dengan x. Okay. Alright, now let's look at for example a, this one can be written as log x base b plus log y power half base b. Okay, and this one you guna property number 1, you akan dapat log of x y power half, okay, base b. Okay, so this is your answer. This is the most simplified form lah. Okay, so now what about this one? Okay, so kita ada plus kan, yang ni kita boleh jadi multiply kan nanti, right, guna property number 2 and 1. So all the base are the same, so kita ada log base x. Alright, and then 3 plus 35, you akan dapat 3 times 35 times lagi 15 over 35. Lepas tu you ada minus, you akan ada divided by 7 over 42. Okay, so yang ni you boleh simplify. Okay, so you akan dapat log base x. Yang ni you akan dapat 3 times 35 times 15 over 35. Yang ni kita balikkan jadi 42 over 7. So your answer will be log of 270 base x. Okay, so that's your answer. Alright, for C pula, I'll just rewrite the question again. 1 over 3 log x base a minus 9 log y base a minus 6 log z base a. Alright, so yang ni pun macam straightforward juga kan. So all the base are a. Okay, so you can rewrite this as log base a. X ni boleh jadi x to the power of 1 over 3 over y ni boleh jadi and this one will be y power 9, and ni will be z power 6. Okay, so that is your answer. Alright, now D is 1 over 4 3 log u base b plus 5 log v base b. Okay, so base b semuanya. So we can rewrite this as kita multiply dulu. We're gonna get 3 over 4 log u base b plus 5 over 4 log v base b. Okay, so yang ni boleh jadi darab, yang ni jadi u power 3 over 4 nanti kan. Okay, so we can simplify it to log base b u power 3 over 4 v power 5 over 4. Okay. Now let's look at a few more examples. Okay, so use the properties of logarithm to find the value of the following expression. Okay, so we have log 81 base 3. Okay, so 81 ni you can rewrite it as 81 is kita kena jadikan dia 3 power of something lah kan, sebab you ada base 3. Log 3 power 4 base 3. So you ada log 3 base 3, you akan dapat 1 kan. So you gonna get yang ni akan jadi, sorry, I'll do it step by step. 4 log 3 base 3, so yang ni akan jadi 4 times 1, so you akan dapat 4 saja. Okay, now what about this one? You ada base 6 semuanya, so you akan ada log 6 24 times 15 divided by 60, so you akan ada log, yang ni dapat 6 base 6, you akan dapat 1. Okay, now this one pula we can simplify this. Jadi log 7 tak boleh. Okay, boleh. On the numerator 14 over 2, which is 97, divided by, on the numerator will be log 7 98 divided by 30 times 15. Okay, so yang ni you akan dapat log 7, yang ni 7 over log base 7, yang ni akan dapat 49. Okay, so this one is 1. Okay, you ada 49, this is 1 over 49, you can rewrite as 7 power 2 base 7, so you akan log 7 is 1, so you akan ada 1 over 2. Alright, now I nak tanya you, you rasa log x plus or minus y base a, would that be equals to log x base a plus log y base a? Alright, the answer is not equal. Okay, so this is not equal. Right. Okay, similarly, kalau you ada this one, log x base a, log y base a, this is not equals to log x base a minus log y base a. Okay, system of logarithm with base 10 is called a common logarithm, ataupun kita panggil ataupun we rewrite it as log x base 10, ataupun in short lagi, kalau you nak kita tulis as log x saja. Tapi kalau you ada base other than 10, you kena rewrite the base. You cannot write it as log x saja. You can specify what is your base other than 10. So contohnya x base 7 ataupun log x base 9. Okay, you kena specify. Kalau base dia 10, you can just rewrite as log 10. Alright, now you pun mesti pernah nampak ada orang tulis ln x. Okay, does ln x equals to log x? Okay, the answer is not equal, ya, sebab ln sebenarnya adalah natural or Neperian logarithm. So selalunya kita tulis the natural logarithm ni as ln x, ataupun sebenarnya kan, as I said, natural logarithm ni sebenarnya datangnya daripada natural exponent. Okay, so ln x ni sebenarnya base dia adalah e is a natural exponent. Yeah, so we can rewrite log x base e as ln of x. Yeah. Okay, so ingat ya, ln x ni tak sama dengan log x. Log x ni is base 10, yang ni is base e. Okay. Alright, so kita tengok sikit on the relationship between natural logarithm dengan natural exponential function. So they are the same curve with x and y axis flip sebenarnya saja, ya. So nanti you belajar dengan Dr. Siti macam mana, how does these two related, and sebenarnya natural log and natural exponent function ni sebenarnya adalah inverse function saja, ya. So on your calculator kan, natural log ni is indicated with ln function, ada you tengok dekat you punya calculator. Alright. Okay, so now here comes the fun part. Kita nak derive the how to change the base of the log. So katalah you have log base a, you want to change to log base b. Okay, so the formula will be log n base a equals to log n base b over log a base b. Okay, so that's the formula. But how do you derive this? Okay, kita boleh derive saja, sebenarnya senang je. Okay, so let's say you have x equals to log n base a, so your index form will be in a power x equals to n, betul ya? Alright, now we take log to base b, sebab you nak tukar base a to base b kan, so kita ambil log base b on both sides, so kita akan ada log base b a power x equals to log n base b, betul? Alright. Now this one can be rewritten as x log a base b equals to log n base b. So your x will be log n base b over log a base b. But your x is actually log n base a kan. So you can write as log n base a equals to log n base b over log a base b. So that is how you derive the change of base formula, yeah. Right, now kita tengok a few more examples. Okay, find the value of the following logarithm to 4 decimal places. So if you cannot find log base 3 in your calculator, you kena tukar base 3 to base E ataupun base 10. Okay, so senang base 10 lah. So yang ni you guna formula tadi tu, you gonna get log 25 over log 3 ataupun ini akan sama juga kalau you guna you guna ln 25 over ln 3. Okay, so you will get approximately 2.9299 ya. Ni kita buat C je lah. So we have log 70 base 5. So kita boleh tukar kalau nak guna calculator log 70 ni base 10 over log of 5. Okay, so you akan dapat 2.6397 something like that. Okay, Allahu Akbar. Okay, now kita move to solving equations related to index. Kita buat index dulu, nanti kita go on sets and also log. Okay, so for example, kalau you have equations of 2 power x equals to 5 power x. Okay, so the power or the exponent is is a variable x. Okay, and this is another example. You have 2 power 2x minus 3 power x plus 2 equals to 0. So these equations can be solved by 3 methods. The first one is method of inspection, i.e. you are comparing the left hand side and the right hand side in the form of indices with same base. And then the second way to solve the equation is by taking logarithm of both sides and use the properties of log. And then the third one is to use substitution y equals to a power x to obtain equation in y. So usually kita akan dapat in quadratic equation. Tak apa, kita tengok the examples. Alright, now the first example is to solve the following exponential equation. We can use the first method, i.e. the method of inspection. You compare left and right hand side. So yang ni you can rewrite this as 2 power 5x minus 2 equals to 4 power 2 minus x. So sebenarnya you nak compare the index, okay, tapi the base is not equal. Yang ni is equals to 2, yang ni 4 kan. But we can change that. Ni you akan dapat 2 power 2 kan, of 2 minus x. Yang ni dapat 2 5x minus 2. So now the base are the same. You punya the exponent saja yang berlainan. So you boleh equate them or compare them left and right. So you, on your left hand side you ada 5x minus 2, on your right hand side you have 2 minus x. Okay, so this is 4 minus 2x, 5x minus 2. So you akan dapat 7x equals to 7. So x equals to 1. Okay, alright, so for B, okay, alamak tak ada space. Okay, tepat pada. For B, okay, we have 5 power x power 2 times 5 power 3x equals to 1 over 25. Okay, so we can rewrite this as 5 power 2, tapi yang ni 1 over 25, so we can get 5 minus 5 power negative 2. So this is 5x squared plus 3x. So you tengok base sama 5 and 5, so you boleh use the you can compare left and right hand side of the index. Okay, so hence x squared plus 3x equals to negative 2. Okay, so yang ni nampak tak, you dah dapat a quadratic equation. So you akan you boleh rewrite this as x squared plus 3x plus 2 equals to 0. Okay, so yang ni you boleh factorize. You're going to get x plus 2, x plus 1 equals to 0. So x equals to negative 2, x equals to negative 1. Now for C, okay, we have 3 power x power 4 equals to 81. So kalau you tengok the base is 3 kan, 81 you boleh change to 3 power of something, betul tak? So you can change to 3 power 4 equals to 81. So yang ni you're gonna get 3 of 4x. Okay, so once the base are equal, so you boleh compare 4x equals to 4, so x equals to 1. Alright, so let's look at another example. Using a suitable substitution, change these equations to quadratic equation and solve. Aku record. Oh, okay, record. Okay, so the first one, we have 9 power x, okay, 10 3 power x plus 9 equals to 0. Okay, so kalau disuruh tukar kepada quadratic equation kan, okay, so kalau you tengok this one, you can rewrite this as, yang ni macam kalau you let a ataupun you let y lah, y equals to 3 power x kan, so you akan ada 10y. So kalau nak jadikan quadratic equation mesti ada macam y power 2 kan, but you look at this one, yang ni you boleh tukar as 3 power x power 2, betul tak? Okay, so nanti you akan ada y kuasa 2 minus 10 3x plus 9 equals to 0. So let y equals to 3 power x. Okay, so you're gonna get this equation as y squared minus 10y plus 9 equals to 10. Okay, and then now you already have the quadratic equation, so you just solve this. Ini apa log? Oh tak 10y. Okay, ni bukan log. Okay, so you boleh factorize this as y minus 9, y minus 1 equals to 0. So your y is equals to 9, y equals to 1. Okay, so that's the answer. No, bukan blah 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 blah. Kan tadi kita we let y equals to 3 power x kan. Kita nak solve the x, okay, bukan y. Okay, okay. So since y equals to 3 power x and your y is 9, okay, so you boleh guna the comparison method. So yang ni akan dapat 3 power 2 equals to 3 power x, so therefore your x equals to 2. Okay, another solution is you have y equals to 1, so y equals to 3 power x, so y equals to 1, 3 power x, so yang ni you boleh jadikan dia as 3 power 0, is it, equals to 3 power x, so therefore x equals to 0. Alright, so jangan lupa to change back what you have substitute. Okay, sebab kita nak solve the x, bukannya whatever yang you substitute. Okay, alright, now let's look at example B. Okay, so we have 4 power x minus 2x plus 2. Alamak, dah pukul 12 nak kena ambil anak. Okay, stop sekejap. Okay, bye. Okay, sorry guys, tadi I ambil anak, I'm back. Okay, tadi kita start kat mana? B Okay, so we have 4 power x minus 2x plus 2 equals to 12. Okay, so yang ni you boleh jadikan, ni you ada 2 power x kan, yang ni you boleh jadikan 2 power 2 power x kan. So yang ni kita rewrite as 2 power 2 x minus 2x, this is 2 power 2 equals to 12. Okay, so let y equals to 2 power x. Okay, so therefore yang this one we can rewrite as 2 power x power 2, kita interchange the power saja, minus 2x times 4, okay, equals to 12. Okay, so by letting substitute y equals to 2 power x, kita akan ada y squared minus 4y minus 12 equals to 0. And then this one you boleh factorize as y minus 6, y plus 2 kan, equals to 0. So y equals to 6 and y equals to negative 2. Alright, then substitute y 6 and negative 2 inside 2 power x, so we will get 6 equals to 2 power x. Yang 6 ni boleh compare tak? Ni tak boleh jadi 2 power anything kan. So yang ni you ambil log lah, I think. So kita ambil log 10 je lah. So we're going to get log 6 equals to x log 2. So x will be equals to log 6 over log 2. Okay, so yang ni x approximately around 2.585 macam tu ya. Okay, we have another one which is y equals to negative 2. So negative 2 equals to 2 power x. So for this one we have no solution. Kalau you ambil log, okay, you akan dapat log negative 2 equals to x log 2. Betul? Okay, tapi do you have log negative 2? So this is undefined. Kalau you tengok on the log punya function, okay, so the graph is only defined at x greater than 0. Okay, so you have no log of negative values. So sebab itulah there will be no solution for this one. So your solution is only this one, x equals to 2.585. Alright, so we've come to the last example. Okay, that is C, 2 power x plus 2 power 1 minus x equals to 9 over 2. Okay, so yang ni you can split this jadi 2x plus 2 power 1 over 2 power x, divided, ni sebab dia negative x. Okay, this is equals to 9 over 2. And then so we let y equals to 2 power x. So let y equals to 2 power x, so you're going to get y plus 2 over y equals to 9 over 2. Okay, alright, so yang ni you samakan denominator, you akan dapat y squared plus 2 over y equals to 9 over 2. Ya, apa dia?
Kereta apa ni?
Kereta apa?
Dia ni.
Ni tahu, Aki buat Lego.
Ni Lego kecil, apa ni? Tembak Lego.
Okay, sekejap Umi nak boleh tak?
Boleh.
Okay, thank you. Okay, yang ni nanti you akan dapat quadratic yang ni kan. Okay, quadratic you akan solve, you akan dapat y equals to half and y equals to 4. Lepas tu you substitute balik in 2 power x, you akan dapat x equals to negative 1 and x equals to 2. Okay, tengok hilang balik. Pelik lah benda. Okay, whatever. Okay, so that's all for today's lecture. So in the next hour of lecture, kita akan habiskan this topic, which is solving equation related to set and also log. Okay, bye bye.